Hi guys, and welcome to today's video on time zones. Hopefully this is going to be really useful. It's not going to be a very long video because there's not a lot of content here, but it does build on the ones I have done previously for this further maths course. If you haven't watched the previous videos, you can head over to MaffsGuru.com if you're not already there and search by chapter and textbook and get downloadable notes and more resources coming soon. There's exam answers too. If you're not wanting to do that, not a problem. If you can subscribe to my YouTube channel, that'd be great. Never going to be rich. Never going to be famous, but it just helps me knowing that you're watching, believe it or not. I sit in a room talking to myself for a lot of hours a day, and it's just nice to know there are people watching. I'm never, ever going to be big, but it's great to know that at least you're watching. All right, so time zones. In a previous lesson, we were looking at what lines of latitude and longitude were, and I keep getting them the wrong way around, but I'm getting better because I'm finding ways of learning it, all right? Latitude and longitude are really important to us. There were lots of maths behind this. SACs are based on latitude and longitude. But one of the most funky things, and that's the great thing about the further maths course, is it actually has practical relevance to the work that we do in real life, our time zones. I'm going to zoom in just a little bit. All right, and these, ladies and gentlemen, are the time zones of the world. It doesn't matter where you are watching this, the chances are the time is different from, unless you're watching it in Australia and in Melbourne, that we will actually be watching this at different times. Why? Well, it wouldn't make any sense for the Earth to have the same time, would it? Because, well, it's at the moment, what time is it now? Looking at my Fitbit, it's 11:41 in the morning. So it's 11:41 in the morning here. Way back in the United Kingdom, it's, well, what would that make it now? It would make it in the middle of the night. Right? It would be very silly if it was dark outside and we said it was 11:41. So we've had to make times so that when the Earth rotates and gets to a certain place, so the sun hits it, we call that a certain time, because we all want to have daytime when it's light and nighttime when it's dark. So here are examples of time zones. Now, sadly, further maths doesn't necessarily understand time zones in the same way. We all think that time zones are beautiful straight lines in further maths. But what you can see here is basically there are strange variations in time zones that mean occasionally they're not straight lines. But for all intents and purposes, for further maths, you need to realize that the world is split up into a number of time zones. In fact, 24 of them. Why? Because there's 24 hours in a day. So we need to realize that time zones are taken in respect to the prime meridian, which passes through Greenwich. Already talked about that in a previous video. And all times on this planet are taken with respect to London. That line that runs through Greenwich, all times around the world are with respect. Now, there are local variations. Don't get me wrong. We have AEST here, which is Australian Eastern Standard Time, as you can see behind me. So zooming out just a little bit. When I was planning this lesson, the time zone in the city of Knox, I don't know why it chose the city of Knox. I'm nowhere near the city of Knox, but anyway, Victoria, was GMT plus 10. So basically, we are 10 hours ahead of Greenwich Mean Time. So this here is effectively a time zone. It's just telling me we're 10 hours ahead. We need to understand this information to help us calculate the different times in different places, all right? So if we know where you are on the planet, then I can work out where your time zone is using some pretty funky and simple math. So here we go. There are 24 hours in a day, we know that. And there are 360 degrees in it. So if we can split those 360 degrees into 24 equal sections, we would know where each new time zone would start by using a longitude. Congratulations. That was me thinking, not you. All right. So, meridians of longitude are actually where our time zones change. So we do 360 degrees divided by 24, which gives 15. So for every 15 degrees we move around the Earth, there is 1 hour of time difference. How is that useful to us? Well, again, if we have lines of longitude, they give me the degrees. If I have two lines of longitude, I can work out their separation, and that will tell me how many hours ahead or behind they are from each other, or from London, or from anywhere in the world that they want it to do. So here's an example. Singapore is located at 1 degree north, 104 degrees east. So here is my map. Here is my equator. Here is London. So 1 degree north, 104 degrees east. So there we go. So let's say that is Singapore, and Sydney is located at 151 degrees east, so over here, but lower. Now again, When we are dealing with time zones, we actually don't care about the latitude. I'm not interested in that 1 degree north or 34 degrees south. Don't care how high or above the equator it is, how high above or below the equator it is. I'm just interested in where it fits on those lines of longitude. And so I know that Singapore is 104 degrees east, and I know that Sydney is 151 degrees east. So can I find the difference between those two angles? I should Coco. 151 minus 104 gives me 47 degrees. So I know the difference between those two is 47 degrees. Well, I also know that for every 15 degrees, there is a 1 hour time difference. So if I have 47 degrees and I divide it by 15 degrees, I get that there are 3.133 hours time difference. Now, obviously in this situation, we don't wind down our clocks by 3.11. So we will say there's approximately 3 hours of difference. But the question is Sydney ahead of Singapore or is it behind Singapore? Now, obviously, because the Earth rotates this way, it means the sun gets to the biggest lines of latitude before it will get to the smallest lines. I've done it again. The biggest lines of longitude before it gets to the smallest. So actually the sun is going to get here way before it gets to here. So in which case Singapore is behind. So what is the time difference between Singapore and Sydney? We would say that Singapore, he says in highlighter, we would say then that Singapore is 3 hours behind Sydney. My handwriting is appalling. And believe it or not, that's actually it for this lesson. The biggest tricks for all of these questions are whether they're behind or ahead, and there are exam questions that I will load up a little bit later on as sort of extra stuff for these chapters that actually trick you by using the behind or ahead thing. And you have to be very, very careful about when planes are flying around the Earth and which way they are flying, whether they're going from west around or whether they're flying towards the east, because that's going to make a huge difference on time zone calculations. And there's been a fairly funky multiple choice questions on that. All right, I'm done. Thank you so much for watching. If you haven't already done so, head over to my YouTube channel and subscribe if you can. Greatly appreciated. Just lets me know you're watching. Send a little shout out on TikTok. Would be greatly appreciated too. Otherwise, I'll look forward to seeing you on MaffsGuru.com or in a later video. Take care and stay safe, yeah?